Hey everybody. I'm sad I can't be here live with you today because I'm actually headed off to Glastonbury, but please put all of your questions and comments in the chat and our team will make sure to answer them. But today we're going to talk about how our team went from a chaotic dashboard soup to a layered observability lasagna. And I'm sure that doesn't make any sense to you right now, and you might be expecting a cooking lesson, but we'll dig into what that means today. Ooh, cool. First, I'm Martha. So I'm a product engineer at Incident.io, and we build a product that handles your end-to-end incident management process. So from an alert firing, paging you, all the way through to writing your postmortem. And I work across the stack, but I focus a lot on the reliability of our product and the observability that enables that. Today, you're going to leave with a process to unsoup your dashboards. And I promise that is a very technical term. We're going to talk about the importance of layering our stack and how you guide an engineer through their debugging process. And then we will end with some technical and practical tips for getting this all to work smoothly. But first, we will start with a story. So our story starts in early 2024. We just finished building our on-call product. So something that handles your alerts and pages you, wakes you up in the middle of the night when your software goes wrong. I'm going to use on-call as an example throughout because I'm sure most people here probably have some experience of being paged. Therefore, you'll also know how important it is that you can trust in your pager and know that it will always wake you up when things go wrong. So reliability is essential. And that's where our story begins, with a really big challenge. So it's January 2024, we have a bare bones product and we're due to release it in just 2 months. And our reliability expectations are really high, so we can't just cross our fingers and see what happens when we release it. It's really meta. Our job is to page people. So if our software breaks, no one else knows that their own software is broken. So that's something we really need to avoid. We designed our system with reliability in mind, but we hadn't actually proved that yet. And we had just 2 months to build that confidence. So where did it come from? For me, reliability boils down to 2 things. So proactive. You need to know that your system can handle all of the things you expect to throw at it on a daily basis, but also reactive. You also need to know that incidents are bound to happen, and what matters is the speed at which you find out about them and then resolve them. And building confidence in these 2 sides is what made me sleep at night in the early days of releasing on call. This new unproven product that's expected to be reliable straight out the gate. And as a team, what we learned is the core thing underpinning both these sides is great observability. But what does great mean and how is it any different from good? Luckily, taking your observability up a level doesn't necessarily mean reinventing the wheel. So today's talk won't include telling you to buy any crazy tools or rewrite everything. It's much more of an approach and a strategy that changed how our stack feels. But a very common problem is soup. And what do we actually mean by dashboard soup? Well, often you have tons of single-use dashboards. Whenever you're in an incident, you're building another one and then losing it to the soup. You're swimming around in all these visualizations. There's definitely some really useful ones in there somewhere, but you're never sure where to go next. And it can feel like you're doing the right things with the right tools, but it just doesn't stick. And back at the start of 2024, that was me. I was working in a system where I didn't feel confident using our observability tools, let alone extending them. And previous companies I'd worked in hadn't got this right either. And I thought observability was always this mess that you just have to deal with in emergencies. But in this talk, we will discuss how I got here. So we've got a really reliable product, and it's been that way since we launched over a year ago. We've got a really lovely observability stack that feels great to use. I've become a really big observability evangelist en route. But the key thing is that it's really widely adopted by our team. It's not just a few keen engineers who care about observability in the corner. So this talk is for you if you've got all the right tooling, but for some reason it just feels bad to use. Maybe you've invested really hard in observability, but you're not sure why it's not been adopted more widely yet. Or perhaps you have a system like us that you need to make reliable and you're just not sure where to start. Cool. So maybe now everyone is really excited about observability and you want to jump straight into building dashboards, but don't. Just building dashboards, metrics, and logs with no structure is exactly how soup happens in the first place. So we start with a set of steps to unsoup yourself. It's an iterative process that we follow when building observability that categorically means that we know it will be useful. It's a bit like TDD or test-driven development as an approach. And I'm sure everyone has varying opinions on whether that's practical when it comes to writing code. But for observability, it's an approach that really solidifies that you're measuring the right things in the right ways. And following this process is what gives us confidence that we can rely on our tooling when we need to. We start with predict. So we state something that should be true about our system. Then we prove. We apply real load to see what actually happens. And we can never, ever believe it until we've seen it. And then we measure. So from those above steps, we realize we can't actually understand what's going on. And then we build the observability to show us. We continually cycle through these steps until we have confidence that our system works exactly as we think it does, but crucially that our observability would immediately tell us if it wasn't. So predict. This is where we're stating assumptions about our system and how it will behave. And we'll leave this step with a list of cases to apply to our system, which it should be able to handle. But to make predictions, we need a really clear picture of our system. If you're working with something more established, you probably have this already, but if you don't, get your whiteboard out. So let's have a look at our on-call system. Essentially, we ingest alerts from third parties like Datadog or Sentry, and we wake people up, make their phone ring. So alerts in and notifications out. Internally, it looks a lot more like this. And this is our real system diagram that we used when working on this. You should split your diagram so each part has a single clear job that can succeed or fail independent of everything else. And back to predicting, we want to take each constituent part of our product and think of a load of ways that it might experience strain. So let's zoom in on our alert ingestion. We want to write down predictions or questions about our ingestion flow. These shouldn't be testable with unit or integration tests. They should be experiences of real load in the wild. So end-to-end system behavior under strain. For us, here are a few examples. So alert storms. If GCP goes down, many of our customers are going to be having a terrible day and huge volumes of alerts pouring into our system. We need to know that we can reliably continue to page them. Or what if someone sends us a load of huge payloads, or perhaps someone tries to extract really complicated values from their alert payload? These are just a few examples of the kinds of things you should be testing, things that are only visible when testing your system in the wild. Once we've got a collective understanding of how our system should behave, we can move on to proving it. Proving that when we exert these predictions on our system, it behaves exactly as we'd expect. Would anybody here feel comfortable deploying critical infrastructure without testing it first? Hopefully not, and you should treat your observability stack, including your dashboards, in exactly the same way. If you just build observability, you tend to measure the things that are easy to measure, even if they're not useful. And you really don't want to find out that your dashboards have the wrong data or irrelevant metrics during an incident. So do it when you build them. The way that we got there was through a process called drills. and I'll talk a little about what that looks like first. Drills effectively meant being in a room in person with 4 engineers, writing out all the ways we could break our system, and then actually applying the load to see what happened. Doing this with the team is what gets everyone really bought in, and we rotated people in for days at a time to circulate the system knowledge. And it's actually really fun. You get to see what breaks, chuck a load of different things at it, and we had a great time. Each day, we'd wrap up with a message like this. So when you're running drills, it's really important to track a few things. How are you feeling about your system? What are you confident about? What's worrying you? What did you test specifically and at what volumes? And what have you changed and improved in your code? These are a really useful resource to look back on and know how your system was performing at the time. And that's the process for our drills, but let's look at a worked example for one of our predictions. So taking our prediction from earlier, we need to know that we can handle multiple customers having large quantities of alerts pouring into our system. And we need to actually apply that load and prove it. It's not enough to say it will probably be fine. The interesting word here is handle. What does that mean? Our success criteria is that our observability tooling shows us that we're fine. And for us, that meant we're doing exactly what our users expect in the time frame they want it. The rest of our app is unaffected, so we're not borrowing resources from other places. And if we needed to, we could probably handle a little bit more load and still be comfortable. So now we actually want to apply that load and see what happens. And we run our load test using Grafana's K6 tool. We had a really simple use case: send increasing numbers of alerts to ingest via HTTP and see what happens. So K6 allows you to send distributed load into your system, and you can see here that we're split across multiple geographic regions. And it also allows you to easily vary the rates you're sending it at. So here we're hitting our alerts with an initial volume of 1,200 requests a minute. There's a load of ways that you can load test, but the point is you want a simple framework to throw increasing rates of requests at your system and track responses. When we did this, we found that we were missing the answers to loads of our questions, and we weren't sure whether we were actually handling this at all. So we didn't know where we were rate limiting, what this looked like to our end user, or which parts of the system were slowing us down. So we've taken a prediction and we've simulated it, and we've got this whole list of questions we're missing the answers to, which means it's time to measure. So we finally get to build some dashboards, and we want to use our observability to confirm that the system behaved like we expected, which likely wasn't true, at least on the first try. And in this section, we're going to talk a whole load about dashboards, but they can be really controversial for a good reason, because it's so easy for them to suck. So before we actually build anything, how do we avoid the soup? There's 2 classic mistakes with dashboards that we want to avoid. Firstly, they answer a really specific question. So they're often a point-in-time picture of something that you knew would be interesting once. It's known unknowns, and charity majors had written a load of great blogs about this. We can't change that. We can't suddenly give ourselves the ability to predict like unknown unknowns. So instead, we have to be really smart about what we ask it. We use these dashboards as a triaging tool, and they allow us to answer the question of how broken is our system, exactly how does it appear to customers. We want to make sure if we're using dashboards, we're choosing questions that will continue to matter. And dashboards are also often static and disconnected from the rest of your debugging stack. If I receive an alert saying database CPU is really high, that sounds pretty bad, but often when I look at my panel, I'm stuck and I can't dive deeper and find specific examples of logs. It's really easy to create dashboards that just leave you stranded and unsure where to go next. The core principle that helps us avoid both of these mistakes is by treating our dashboards as a product. So the way we make our dashboards good is by constantly putting ourselves in the shoes of the engineer using them. So think about UX throughout. Incidents are really stressful, and you want your tooling to let you work quickly and with confidence, not get in your way. The way we do this is through a consistent framework applied across our stack, which is our lasagna. So a great observability stack will walk you all the way from a bird's eye view down to individual requests. And this is our lasagna. So we've got 4 key sections. We start with a really high-level overview dashboard, move through a more specific system dashboard, logs, and then traces, which is our most granular detail on specific requests. And having this consistent framework means engineers don't need to see every dashboard before they reach for them in an incident. It's so important to be able to dive into unknown observability territory, but feel right at home. And the engineer's journey through these layers is what we want to optimize for. So when we think about what the most important piece of our lasagna is, it's actually the arrows. And these layers are ineffective and won't be adopted if it's not incredibly easy to navigate from the top all the way to the bottom. So that's why it's really important to connect our layers. That means drawing the arrows yourself and knowing exactly how an engineer debugging will arrive at the next step down. So every time you build a visualization or instrument something new, you have to ask yourself where you'd point yourself next and give an engineer a really nice big button to click. When we think about the stuff that underpins these dashboards, that means having really clear links between metrics, logs, and traces that you can lean on when you build your panels. So let's dive deeper into those actual dashboards. And we start with our overview dashboard. So this is the most high-level view of our system, and it sits at the product level. So we have data overview dashboards for each major part of our product offering, like on-call. And our overview dashboard is every engineer's first stop when they realize something is wrong. It provides a traffic light for each subsystem that makes up that product, so signals that you can understand at a glance. And it's ultimately a triaging tool. So it won't give you the full details of what's wrong, but it needs to be glanceable and let you quickly assess impact and act as a signpost to point you towards the next step. We put this dashboard everywhere. So it's our Grafana homepage, we bookmark it in Slack channels, and teams should view this as your first stop when you know something is wrong, whether you're in an incident or not. So this is our overview dashboard during our load test, and it contains a load of rows. Each one is aimed at quickly telling us if there's a problem with that area of the system. We start with infrastructure health. So what's the state of the core pieces that our system relies on? Zooming in, we run on Kubernetes with a Cloud SQL Postgres. And that means we plot CPU and memory for the relevant pods and database health, including CPU and pool saturation. Next, we have queue health. We need to identify if we're behind on async work. We plot count of unactive messages for each of our subscriptions, basically how many items are in the queue. And right now, this looks messy and not interesting. That's good because everything is behaving as normal. And when there is an issue, this graph will have a really clear single spike. Next is rate limits. What traffic are we blocking and where is that happening? Then for each of those key sections in our system that we saw earlier, we have a row which is a really clear picture of whether it's happy or sad. Alert sources is our alert ingestion, alert routes, and then we have escalations. So are we paging people? Taking a closer look, our escalation system runs on a Postgres queue. So we need to know that we're processing it at a healthy rate. We track the oldest item in the queue and how much of our capacity we're using. It's really important that if anything is wrong, this looks really red and scary, it's okay if that's a false alarm or it's only a minor issue. You want people to glance at this row and quickly understand whether they should dig deeper. As you can see, this is running during our load test, and we've got a bunch of stuff in progress, which would make me want to dive deeper into the problems with the escalation system. And going back to our connecting layers principle, I can click right there on the escalations title, and it will link me directly to an in-depth system dashboard. So that's our overview. It's a simple traffic light of which areas of the product are healthy, encouraging us to quickly triage and dig deeper. Once we've identified a problem, we then move to our more specific system dashboard. So we come here when we know there's an issue with a system, but we don't yet know the impact or what's going on. So this dashboard is an exhaustive picture of how well a system is doing its job. So we want to plot everything that could impact that against time. If an engineer is here, they want to deepen their understanding, describe the scale of the impact and whether it's getting worse. So this is where you'd plot your SLIs or service level indicators. And SLIs are a whole separate talk, but there's some really useful frameworks here, including RED or the 4 golden signals. The key thing to aim for is understanding real customer impact. And that's exactly what we want to work out with this dashboard. Finally, these should link you straight to logs. So your dashboard is absolutely not useful if you can't give people granular examples of things going wrong. Looking at our escalation system dashboard, as we said, we run on a Postgres queue, so we need to know that we're keeping up with load and processing it sensibly. And these dashboards will look different depending on your system's single job, and that's normal. So lean into what's interesting and don't make these fit a particular mold. So we start with a section on capacity and how much we're using. It's really important that you know how much your system is saturated so you can decide how quickly it might get through a backlog. We plot the amount of work we're doing against our capacity, and we'll dive a lot more into this metric later. Next is throughput. So how much are we processing and how quickly? Then user observed delays. Once an alert fires, how long is it until I get paged? And then outcomes. So what is actually going on with my escalations? And this is a lot more granular than success or error. I want to know what types of actions my system is taking and what's actually happening internally. And finally, the last section of each system dashboard is always logs-based queries. This is so important. It gives an engineer the ability to dive into specific examples of what went wrong. We have a filter which allows condensing to a single customer, so you can really quickly find targeted logs that you care about. Cool. So we've used our system dashboard to understand the issue, the scale of it, and now we're ready to dig into logs to see a real example of that. And logs are a really useful debugging tool when you actually know what you're looking for. So your logs should show your engineer the journey of a request as a single unit of work, detailing what happened and when. You want consistency across your systems. So I've been in a scenario before where I have 10 different bookmarks for different log searches to make sure I cover all cases. That's really slow in an incident, and you need to have a really solid pattern for your logs. So it should be impossible to stray from nicely formatted, useful logs that are easy to query. Once we've found an interesting log, a trace is likely the final piece of our puzzle and will always be linked to it directly by our trace URL field. And traces give us the most zoomed in look at a single request for up-close debugging. You probably don't trace all requests for cost reasons, so you might sample these or just show errors. So we want to know that when we do have them, they're really useful. So traces allow us to connect the dots on where a request spent its time, which is particularly useful for slow requests. So anything where you have to rely on someone else should be traced by default. You need to know that a 1-second external API response was your bottleneck. So an example of that is having a single shared base HTTP client across all third-party requests so that that's added by default. And then just like logs, we want a really simple UX for engineers to instrument tracing in their code. People should know how to reach for these tools and where to plot functions that are slow and add tracing. So that's our lasagna, and this framework is what makes our observability UX amazing. The layers are what gives this consistent and understandable experience to anybody debugging. This is a journey I perform all the time. So last week, I got paged for high CPU on our on-call worker. I head to our overview dashboard and diagnose it as an issue with our alert routing flow because I see high latency. Then I head to our system dashboard and I see that it's a problem specific to a single organization. I find an example log and look at the trace and learn that it's a locking issue. So I've gone from a really vague alert to a really specific diagnosis with my hand being held through our observability stack throughout. And there's a load of technical details that make this work. So we're going to end by going through some practical tips for how we make our dashboards feel good. So firstly, always think of user impact as your lens. If you've ever been paged for CPU hitting 70%, you'll know that that kind of means nothing on its own. It's a warning sign, but it could mean nothing is currently on fire. And what actually matters is what the users of your system are seeing. So classic metrics like CPU, memory, or latency are useful, but what makes your observability amazing for triaging incidents is the addition of business logic that can only come from your knowledge of the system. So this is your job, to know what questions actually matter and answer them. How do we layer that in? First, we have an outcome field. So each of our systems has a single key job, and basically you should be more granular than success or failure. So what are your customers actually seeing? Are they being paged? Are their escalations expiring? And this is really easy to add and cheap. We already track a duration metric for our processes, so we also want to add an outcome alongside that. And it introduces this layer of actual impact and outcome to your metrics. And we also track user observed times. So plotting latency is useful and we all default to it for a reason. But traditional metrics sometimes don't tell you the story of what a user actually experiences. So challenge yourself to think of it that way. Often these days, things go through multiple async processes and different queues before they finish. So think wider than how long is my function taking to run to how delayed does this look to my user. For us, that means tracking execution delay. Basically, what was the time between an alert firing and a user actually being paged, and what does that feel like? This graph just here was on our dashboard during our escalations load test. So whilst I saw high load and high CPU, our actual execution delay to users was absolute worst case 2 seconds long. And this is really comforting. It means that we immediately know the scale of an issue. And I always look at this panel first on any dashboard when I know something's wrong. It really quickly gives me an idea of the impact so I can triage how bad things are. Our next tip is connecting metrics to logs. So we said connecting those lasagna layers was the most important thing for UX when an engineer is on a debugging journey. And the best way to do that is to make sure we're always behind the scenes connecting metrics and logs together. So we never just want to have a thread that we can't pull any further. We do that with event logs. So every metric tracked on an individual request should have a corresponding log that you can search on. So we call those event logs, but they're also called anchor logs or high cardinality events. They're a pretty common pattern in observability. It's a single, consistently formatted log that anchors your request and tracks your metric values. And you should include everything that you track in your metrics, but expand on it with really specific IDs and detail, because it makes your life so much easier. The important thing is you always need to log this every time, even if it errors, because in the nightmare scenario where you're in an incident and your code has panicked, you really want to make sure that your log is still there. In Go, that means we wrap it in a defer, but just make sure that you have a pattern in your code base that everyone knows how to make sure they're always logging their important metrics and logs. So exemplars are another way that we connect metrics to traces. So these little dots on my graph are single trace representations of my metric value, which I can select and then click on to view the trace directly. They're a really useful tool to bridge that gap between metrics-based charts on your dashboards to actual requests in your logs. And using that in the code looks something like this. So every time we increment a metric, we sometimes also add an exemplar. And these are really useful when looking at latency-based metrics, where I want a really specific example of something that was slow. And our final tip is visualizing limits. So charts are so much more useful when you have the context of how bad things actually are relative to your system's capacity. It makes it way easier to quickly triage how long you have before things get really bad and how quickly something might process. This isn't always possible, so not everything has a ceiling or a breaking point, but when they do exist, make sure you put them on your graphs. So one way we do this is through plotting work. Work is basically a metric of how much is my system occupied at once, and it's tracked in seconds per second. So in our escalation system, we have 2 escalation workers per pod and 3 pods. So 6 total concurrent things at once, and we physically can't do more than that. So our capacity is that line at the top, and it's a limit of 6 seconds. And you can also see our work in the green and red bars. And this is during our load test. So you can see we're entirely saturated and we couldn't go any faster if we tried. The really interesting thing here, though, is to make your limit a metric rather than a static value. So on our 6 seconds line, you'll also see the dips that seem to follow right after we deploy. So when we know that we're doing less work, when we've plotted our capacity, we have a really clear explanation for why that happened rather than guessing. So having your limits as a live metric gives you real confidence that you're working with the capacity that you expect. So there are tips, and these things will make it super easy to build useful dashboards, and they're things that your team should all understand when they're contributing to your code base. Cool, so we've spent all of our time building amazing observability and doing our predict, prove, and measure flow. When are we done? And I'm sure it's a little bit painful to hear that you're never really done. Software is always changing and dashboards are living. But when we put this project down, our longevity has been great. Our team makes small tweaks from time to time, but the core dashboards and structure have remained alive for over a year, and people are using them more than daily. But there are a few things that should tell you it's time to trust your system and your observability. Mostly that you have thrown all sorts at your system and you're happy with how it's coped. You've always been able to see when it's unhappy through your observability tooling, and you've understood its limits. At all times, you've known the impact on customers and what they're actually feeling. And then your team can all do the same, and you feel confident that they could handle this in a real incident. So don't do this on your own. Anyone could build a beautiful set of dashboards and logs, but there are many more people contributing to your code base and fixing your incidents. So you can't be the only person that knows how to handle things quickly when they go wrong. And doing this with our team is what gave us confidence in our system. So reliability isn't just your code, it's whether whoever's on call can quickly handle it and triage the issue when something goes wrong. The expectation isn't that everyone is an expert in these tools, but it's really important that your team can use them to triage quickly Whether it's a momentary blip or a full-scale production outage, we need to determine that fast. And doing this process, so running our drills, building dashboards, and exercising our system with the team is what got us trust and buy-in in our tooling. You've built this amazing observability tooling for them, and you need them to use it and own it. So run everything with them, get them to build your dashboards, and run sessions showing how you debug issues using them. One extra thing here is game days. So if you think of our drills earlier as a test with the textbook open, no wrong answers, they were basically a learning exercise. Well, game days represent throwing you right in the deep end and expecting you to use the observability tooling that you have. So we run game days quarterly, and they're mostly to test our incident response. So we focus on comms, how we work together, but they're also a really nice way when you think your dashboards are great to see how they're actually used in real life and how useful they are. So we've used this to spot places where people are missing tooling and right up where we want to invest further. Cool, so that's it. Basically, good observability shouldn't come for free with nice tools, and that's your job to understand your system and what you should track. Doing that from theory alone is really hard to get right, so using that predict, prove, and measure flow makes you certain that your observability will actually tell you how things are going. Once you've got that down, apply principles to your observability and make sure you're always coming at it from an UX angle for the engineers using it. And that means always knowing how your system is feeling to users, because that allows you to triage so much faster. And do it with your team. So doing this process with someone else in your team shares knowledge and gets everyone collectively more confident. That's it. Thank you very much for listening. I will also say that we're hiring at the moment. So if observability, incident tooling, and all of this stuff sounds interesting, definitely reach out to us. And I hope you have a lovely rest of your day. Bye.